Hey, so today I'm going to go over a generative design simple hook. Generative design can be kind of a complex design mechanism, so thinking of what's the easiest thing to make and simplest, and that is just a hook to hold a simple thing on the wall. So I'm going to start off by making the model. Now you can do this in the design tab, and it's usually recommended to do that because once you're done under the generative design tab, then you can continue to use that model. But for this, I went under generative design and just edited the model directly from there. In designing the bodies for this, you're thinking about two things: preserve and obstacles, or preserve geometry and obstacle geometry. With the hook, you have the actual hooking part as a preserve, and then whatever is going to that in the wall doesn't need to be preserved. That's what's going to be generated. But we are going to have to preserve the wall as well. We can remove that at the very end, so we just have the hook, but we do need to design the wall in there too. Then we have to think about the obstacle geometry. Now, inside the hook, you want to avoid that area so that when the model is made, nothing goes in where you want something to hook onto. So that is what this inner circle is going to be. It's going to be the area we want to avoid when generating the model. With the avoid geometry, I realized that I don't want to just avoid the inside of the hook. I also want to avoid the area above the hook so that when you put something on, there's not something impeding it on its way to the actual base of it. So kind of put a triangle just above it to sweep out the area that will be used to place the object on the hook. And now I'm going to turn these sketches into bodies. I'm just going to use a simple extrude with using symmetric on both sides. Preserve is going to be the wall, and it's going to be the actual hooking element, the part of the final hook that is preserved. So anything outside of almost just a surface is what we're going to preserve. And I'm making sure to use new body for all of these components so that they don't join together. So now you can see there's a green and a red for preserve and obstacle, and I'm going to select each of those accordingly. So the wall and the hook, preserve, and the area swept out as the obstacle. Now there is a symmetric plane, and this does have a plane of symmetry right along the very center. However, I had some issues with that, so what I'm planning on doing here is just designing it normally, and then at the very end, cut it down the center, pick the half I would like, and then mirror it. Then under design conditions, I'm going to put structural constraints, and I'm going to constrain the wall into place. That's because in this design, the wall is going to be what's not moving, and the hook is what's going to be attached to it. And then also under design conditions is structural loads. These are going to be the loads that the hook is going to have. I'm going to start with load case 1, which is just going to be, what's it kind of static? We're going to have a weight directly on it pointing straight down, and that's what the blue arrow is. The yellow arrow is on by default, and that will be for gravity. Usually negligible in a lot of designs. But for this, we're going to do 4 load cases initially. 1 load case for straight down, 1 load case for into the wall, and then 2 coming out the wall. Adding various load cases for generative design is really important because it will design only to satisfy a specific load case. If you don't have a certain load case, like in this first design, they don't have any load cases that are horizontal. They're all kind of either in the wall or straight down from the wall. So you can see in the first attempt, it came out very thin because it didn't compensate at all for any lateral movement to the hook. And then all the forces I'm putting on here are 25 newtons, which is just kind of an approximation. If you're working with something that needs to be very specific and you can get the load cases for that, you can get very optimized designs through this method. All right, then after the load cases are done, we're going to go over to design criteria and do objectives. For this, I'm just going to do minimize mass. There's a few other options for specific cases. And then you need to go over to manufacturer methods. All my designs are typically for 3D printing. So I keep additive, and then I also like the unrestricted as well. The outcomes from unrestricted and additive tend to be fairly similar, but you can select the orientation under additive and the minimal thickness and angle that it will converge towards. Under unrestricted, it won't have any limitations. You put milling or two-axis cutting on for your manufacturing methods, you'll see the design will come out very different. And then it's over to materials. There's a pretty large material library to choose from. And for this, because I don't know the exact load cases and I'm just kind of eyeballing it, one thing I like to do is do various materials. So some materials which have a higher strength than others. So in case I need additional strength, some under materials, I like selecting a kind of a wide variety in case the load cases are too heavy or too light. I can pick a material that compensates for that a little bit. Even though most of these designs will be out of PETG at the very end or ABS. And after materials are selected, you should have all your pre-checks done. You'll see under Generate, the first box has a check mark in it. That means all the conditions are set. And then the one to the right of that is a previewer. This will kind of do a bounding box around the entire thing and show where it's going to have a lower resolution of the final objective. Now I'm noticing that it's building to the right of the preserve geometry, and I don't really like this because that's going to impede anything kind of holding on to it. So I'm going to go back into edit model, and I'm going to select the body that was the avoid geometry and widen that out. So now there shouldn't be any area for the design to generate along the side and kind of force it to build under it. As you can see, that's now building underneath the design, and anything that's going to hook onto it now has won't be impeded from being able to clip on. And the previewer can take a little bit of time to fully generate a previewed model. But what I'm really looking for when I click that button is make sure it's not building in areas that I don't want it to build, and it's kind of converging where I think it should. And then to the right of that one is generate. This is where you can generate that model. So I'm going to generate one study and take some time to upload, and then show you the results in a minute. This generated 22 models based on the data that was put in. So each of the materials with the different load cases, or with the different manufacturing methods. And when it says converged, that means the model's done. There's still a few processing, but after looking through a few of them, I noticed that some of the designs, they aren't looking how I want them to. It looks like I missed some initial data. So I'm going to go back and add that data to it so that it generates the design I kind of want. You'll notice it's very thin when looking straight on, and you also have that big, like the hook is still very visible. It's not morphed into a kind of a single body. Kind of want that smooth transition from the hooking element to the body itself. And that was similar to each of them. So to correct that, I'm going to start off with kind of making that hook smaller. It doesn't have to have that thickness to it, as well as this that kind of spike coming out the back. To help with the transition from uh, the preserved geometry to the generated part of the model, I'm going to fill it each of the corners so that it has more of a rounded surface to hold on to. So I can notice the end geometry for the preserved is pretty small, as well as the wall, but the wall will be removed at the end. And then the obstacle geometry seemed to work well. And then to fix the fact that it's very thin and I want it to be able to withstand some side forces when an object is placed on it, because not everything is going to be immediately sitting straight on. Sometimes you might bump the hook a little bit to the left or right, and I want to be able to compensate for that. So to do that, I clone the load case 2 more times, and I'm going to take those arrows and point them at a 45-degree on each side. So now when it's generating the model, it has to also generate it for being able to take those 2 forces. And then under manufacturing, I'm also just going to take off the additive one and just leave it on unrestricted. And in a lot of cases, the additive solution as well as the unrestricted solution tend to be very similar. And I'm just going through checking that each of the arrows are kind of all pointed in different directions. So we have a load case and checking to make sure the arrows are pointed in different directions so that there's a load case going in each way. And then time to generate the outcomes. So this one came out a lot thicker in the sense that it now looks like it can take a little bit of force from each of the sides. They each converge fairly similarly, so that I just picked one of them and I'm taking a look at it. This is a little bit closer to what I had in mind for what I wanted the generative design to come out to. So this is my favorite aspect of generative design, being able to look at how it approached that final solution. So it starts with a large kind of bounding box, encompassing all the preserves and staying away from the void geometries, and then takes away the least used material. So you can see it kind of slowly converging towards that final design. Then you can do a design from outcome and bring it back over to the design tab. So now you notice there is a little bit of asymmetry there. So I'm going to split it in half. And then split the body, pick my favorite half, and mirror it. I'm looking at it straight on. See that lower right leg kind of looks a little off. So I'm going to keep this left side and then mirror it from there. And then I'm going to do a little bit of cleanup work. Each of these edges that are starting to be a little bit sharp, I'm going to fillet them just a little bit so it has a smooth transition everywhere. And then I'm going to pull this lip just a little bit down. It looks like a weak portion of it. But that's how you do a simple generative design hook. Doesn't need too much modeling to make the design actually happen. There's only 3 relatively simple bodies involved in doing this. The harder part is understanding the preserve and the obstacle, and it might not be entirely intuitive that you need to make the a void geometry rather large to compensate for all um, the space you need to then place the object on the actual hook itself, as well as how to put the load cases to kind of get the outcome you want. If you have any suggestions for things you'd like to see generatively designed, let me know. Otherwise, see you next time.